All right, so today we're looking at problem 08F-59. So it involves calculus, which is good practice for most of us. And I'm going to try my best to avoid having bad handwriting. Now, the issue I have though is I have this new writing pad, which is pretty useful, but I haven't gotten much use on it. So I'm going to do I might have some bad handwriting time to time, but y'all gonna have to bear with me on that. Fortunately, we do have a virtual calculator, a calculator emulator, so at least you can see what I'm typing in pretty clearly. But when it comes to the writing, it might be a little bit poor. But it'll get better, right? It'll get better over time, the more practice I get. So, starting with this problem, it tells us that the axis of revolution is y is equal to -3. So there's, like, we could just imagine y is equal to -3 is equal to -3. And we're revolving this shape right here, the shaded region, around that line. Now, I can't quite demonstrate that. There's plenty of images and GIFs, that'll show lines or areas being revolved around something. But I can't quite tell you how that would work here. But the whole idea is with calculus, we can take the integral of this area. If we integrate from 0 to this intercept of the area between these two lines, if we revolve that around this line right here, then we get our volume, right? Because as you know, area multiplied by like a third dimension gets you volume. So I'm gonna start setting up the integral, uh, and the form here is going to be big R minus little r. And what I mean by that is big R is the one that's furthest out. So in this case, it would be x is equal to 4y squared. I'm going to change that to be y equals since that's easier to work with, and the other one is y equals. So most of us should know how to isolate for a variable. I'm not going to show the steps, but if you have 4y squared, the first thing you do is divide by 4, right? So you get x over 4 is equal to y squared, and then you just take the square root. So you end up with the square root of x divided by 4 for this line right here. And that right there is our upper bound, as you can tell. So that's our big R. But that's that's not exactly a big R yet because the line isn't the x-axis that it's being revolved around. The line that's being revolved around is y is equal to -3. So the distance between this line here and the line of rotation, axis of revolution, is that line square root of x over 4 plus 3. So I'll show y'all right now how you could do that. So the square root of x over 4, again, I missed that right there. X over 4, it's kind of came out poorly. Uh, x over 4 plus 3. That's our big R, right? Squared. Now our little r is the line below it. So that's 6x squared. And again, that's not just 6x squared, that's 6x squared plus 3. So we're going to do minus 6x squared plus 3. Now we're set up pretty well. Now, the whole idea of this is that we're making an infinite number of circles, right? That's where the r squared comes from. So if you have this is actually called a washer, right? A washer or a washer, depending on how you say it. But it's in essence it's a circle, but there's an inner circle that is missing. It's a hole, right? I mean it's what it's in the name, right? Washer. You could look one up. Let me actually show you one. If I can move my pen out of the way. If I find a washer, you could understand what's actually going on here. Washer calculus. Okay. I hope they show a better diagram here. Okay, this'll do. So this right here is roughly what is going on here. There's a big circle, right? And there's this inner area, another circle that is a hole. So that's a washer. This right here is also good demonstration, right? You have big R, that big area, minus a little area. Both of them are circles. That's what we're doing here, right? We have this big area, that's the big radius. This right here is the little radius. So now we have the formula for a circle, which is r squared times pi, right? This formula just takes that pi outside the integral. So you have to make sure you slap in a pi outside the integral. Pi times this interval. I'm actually going to rewrite that because it looked weird, slanted. Pi times that interval. Now the lower bound of this is just 0. And the upper bound appears to be the intercept, which I don't know the intercept off the top of my head. I could do some working on it, set them equal to each other. I'm just going to use the numeric solver since that's faster, since we're all about time. So the square root of x over 4, set that equal to 6x squared. And you get what that upper bound is. I guess I already had it saved. We have the upper bound. If you had it set to 0, 0 is another time where those graphs equal each other. So you'd have to go for a bigger value, which would get you what the upper bound is. So now we have our interval. Let me first put a pi outside. Pi times the square root of 0 to, I forgot to write it up here, but it's 0.191 roughly. 0.191. I'm just gonna write 0.191 right here, or I'm gonna go x because it's saved under x. Always use the most specific answer, the most specific variable. And then we have the square root of x over 4, x at the square root plus 3 squared minus, in parentheses, 6x plus 3, or I think it's 6x squared plus 3 squared is equal, and then dx. All right, I think I forgot to write a square right here. There we have it. So square that. So big R squared minus little r squared. You find the integral, you multiply by pi. And our volume is now 0.270. Awesome. So that is our first answer. I'm also going to do the other problems on this page, and hopefully they go faster. All right, Future Thomas here. I'm going to post the other walkthroughs on these problems on the page in the following videos. I'm probably going to post one a day. But if you want, you can see the 5 problems coming up, so you can feel free to work on them yourself. In the time I spent solving it, I did it just one whole take. So you probably won't have much of an intro these next few videos. Since I'll be focused on just going and hitting the problem right away. But again, thank you for watching. I hope you come back and you see some of these other videos. If you learned something, feel free to comment below. And if you have any advice, I'd be happy to hear it. So, all right, but keep an eye out. Again, within the next week, these videos will be coming out. So, all right. Well, thank you again for watching, and hope I get to see you again sometime. All right.